Hello to everybody that is listening in front of his computer. I'm Marc Schäfer and I will present now the results of the disease monitoring of our Be Good Pilot A and Pilot B studies in 2020. In the Pilot A study there were 8 mini-apiaries from our 8 partner institutes. The locations of the apiaries are seen in the map. Number 1 in Ghent, number 2 in Wageningen, 5 in Avignon, 6 in Halle, 7 in Cluj-Napoca, 9 in Coimbra, 10 in Nottingham and 12 in Bern. The Pilot B study consists of 25 colonies with 5 different treatments, and they are located in number 2 Wageningen. All the Pilot A mini-apiaries consist of 8 colonies. And all colonies of Pilot A and Pilot B study are sampled 3 times per year. First in spring, when the bees start to forage, second in summer, when the colonies have reached their maximum size, and a third time in autumn, just before overwintering. In the table, you can see which pathogen, parasite or virus is analyzed in which of the samples of which season. In the Pilot A study and in the Pilot B study, all the laboratory analyses are done by the lab of Severin at CM5 in Belgium and in my lab at the Friedrich-Loeffler-Institut in Germany. Half of the locations, half of the partners are sending their samples first to Belgium, and the other half are sending their samples first to Germany. In Belgium, all samples are analyzed for acute bee paralysis virus, chronic bee paralysis virus, Nosema apis, Nosema cerani, and Pennibacillus larva. In Germany, the samples are analyzed for black queen cell virus, deformed wing virus, variant A and variant B, sackbrood virus, and Melissococcus plutonius. After one of the laboratories is finished with their analysis, the homogenates are sent to the other laboratory to finish all the other pathogens. And in both of the laboratories, the samples are investigated for the Varroa destructor infestation level and the amount of Nosema spores per bee. As we sometimes did not get enough bees, I would like to state here that one sample should consist of around 300 bees to have enough bees for all the Be Good laboratory analysis. So not only our analysis, also the analysis of other partners afterwards. So therefore it is very important to explain this to all the participating beekeepers, as beekeepers mostly try to sample as few bees as possible in favor of the well-being of their colonies. And furthermore, it is also very important to send the samples right after the sampling, as the results of the analysis are needed as soon as possible for the modeling and also maybe to keep the participating beekeepers motivated to be part of the project. So let's start to have a look at the results for the Tier 1 Pilot A study in 2020, and I will go now through all the different pathogens one by one. For more clarity, the plasmids with the viral loads or with the DNA pathogen loads were added to all our analyses, and we had 3 different defined dilution of plasmids, and according to the results of these plasmids, the results are ordered to different categories. So if a low amount of the pathogen was found, this was here shown in yellow or in a table with an L. If a medium amount of the pathogen was found, this is shown here always in orange or with a letter M. And if a high amount was found, this is shown in red or with the letter H. So for deformed wing virus, we can see that not much was found at all, and that it a little bit the virus values got higher over the year. This looks very different if we look at the deformed wing virus variant B. So this is very common in our colonies already in spring, and it rises over the year, and in autumn 100% of the colonies were positive, and the viral loads were very high in autumn. Looking at acute bee paralysis V, we see that about less than half of the colonies were positive in spring, and also here it rose, and in autumn more than 3/4 of all colonies were positive, and also the viral load was much higher than in spring. Chronic bee paralysis virus was not as often found as acute bee paralysis virus. There is less than 1/4 positive in spring, and a bit more, let's say 1/3 of the colonies were positive for chronic bee paralysis virus in autumn. Looking at the black queen cell virus, we see that 100% of all the samples were positive, and that the highest viral loads were found in summer. Looking at the sackbrood virus, the picture is very similar. Only in spring, not all of the colonies were positive. And also here for the sackbrood virus, similar to the black queen cell virus, in summer we found the highest viral loads. In none of the samples we found Nosema apis, but we could find Nosema serrani, and about 40% of the pilot A study colonies were positive for Nosema serrani in spring, and a bit less than 30% in summer. Melissococcus plutonius, the agent of the European foulbrood, was found very seldom. It was actually only in one location, and Penibacillus larva was found only in one sample. Penibacillus larva is the agent of the American foulbrood. And on the right side you see the samples that were positive for Varroa destructor, and you see that the percentage of colonies is rising from spring to autumn, and in autumn almost 60% of the colonies were found positive for Varroa destructor. Let's have a look to the locations of our mini-apiaries and the results of the locations, or at the locations. For more clarity, I also set categories here to our Nosema serrani results and the Varroa destructor counts and the Nosema spore counts, and I adjusted it simply. We didn't have any plasmids for the Nosema, but I adjusted it to the CT value. If the CT value was lower than 20, I used red, so meaning a high load of Nosema serrani, and if it was higher than 30, I adjusted it as low, and in between as medium. For Varroa, if there was one Varroa found in 100 bees, I said this is a low infestation rate, and if it was 5 or higher, I set it on a high infestation rate, and for Nosema spores from 0 to 100,000, I set it on low, and if it was more than 1 million spores per bee, I set it on high. So in Avignon, we found a few samples positive for deformed wing virus A. A lot of samples were very high loaded with deformed wing virus B. And looking at the acute bee paralysis and chronic bee paralysis virus, we could see that the chronic bee paralysis virus was only found in 6 of the 8 colonies, and like expected only in spring. And most of them were also positive for acute bee paralysis virus. In Avignon is the only place where we found samples positive for European foul brood, and the Nosema rates and the Varroa infestation is quite average. To Halle, we can see that the deformed wing virus variant B is also there 100%. The viral loads were a little lower compared to Avignon. And surprisingly here, we had very low rates of chronic bee paralysis virus, but all in autumn and not in spring. The other viruses are always very common, and Nosema rates are kind of average, same as the Varroa rates. Looking at Nottingham, here again we see very high loads of the deformed wing virus B variant, nearly no chronic bee paralysis virus, the acute bee paralysis virus in average, and very few Nosema serrani, like only one colony was actually positive for Nosema in Nottingham. At the University of Bern, we unfortunately had only results for summer and autumn, as due to COVID-19 measurements, no samples could be taken in spring. The results are kind of in average to all the others. Also here we found some chronic bee paralysis virus in autumn, but we cannot compare them to the spring results. But interestingly, in Bern, we have seen that one colony B died in summer or during summer, and this colony had a very high load of deformed wing virus B, and it was also highly infected with Nosema spores. Another colony, F, died during winter, and here we can see also a high deformed wing virus B load and a very high infestation level with some Varroa destructor. The colony I was added during summer to replace the dead colony B. Looking at the colonies in Cluj-Napoca, we can see that here we actually had the lowest rates of deformed wing virus B of all the locations, which I think is very interesting. And no chronic bee paralysis virus was found. And the rest was kind of average, like with all the others. However, in Cluj-Napoca, we had 2 colonies that were not sampled in spring, as they were in the process of changing the queen and they didn't want to disturb the colonies. And in summer, the region was confronted with significant depopulation, and therefore 3 new colonies had to be added in autumn. And if you look here at the Varroa destructor infestation levels, there was a misunderstanding with my technician, and all those samples which are marked with a star, I didn't explain this before, are those that had less than 100 bees per sample. So if we find samples like this, we usually count them individually under the microscope. We count the mites under the microscope, so we don't wash these bees. If they are more than 100 bees, usually we use around 200 bees. We wash them in alcohol to count the mites. So here we had numbers much lower than 100 for all the autumn samples, and due to a misunderstanding between me and my technician, those were not counted. Looking to the mini-apiary in Coimbra, the most interesting thing here is that we find the deformed wing virus A variant in nearly all of the colonies. And on the other hand, we have no infestation with acute bee paralysis or chronic bee paralysis virus, and only very few, like only one colony was positive for Nosema cerani, and the varroa numbers were also quite low. And in Coimbra, the only colony where we had a positive result for Pedibacillus larva, the agent of American foul brood, was found. As this is a notifiable disease in all Europe, the partner was notified, and bee samples were checked to see if we in microbiological methods we can find any spores. With the bees we couldn't find any spores, but we asked the partner to take a honey sample, and the honey sample of this colony was positive. In University of Ghent, the deformed wing virus B was low compared to others. The levels of acute bee paralysis virus and chronic bee paralysis virus, except of one chronic bee paralysis virus sample, were low. There was also nearly no nosema found, and also the varroa loads were quite low. Looking at the mini-apiary in Wageningen, is, if we look at all the results, kind of averaged to all the other locations. To sum up the pilot study A results, so we found differences between the seasons. The viral loads of viruses and the number of varroa mites usually increases from spring to autumn, but black queen cell virus and sac-brood virus are an exception here, as we found the viral loads there were highest in the summer samples. And in general, we found very few cases of EFB and only one case of AFB. Then we saw quite interesting differences between the country. We had in most of the country a high viral load for deformed wing virus B variant, for black queen cell virus and for sac-brood virus, but low deformed wing virus B in Romania. And deformed wing virus A was very seldom, but we found it in nearly every colony in Coimbra. The viral load of acute bee paralysis virus and chronic bee paralysis virus differed between the countries, like we had no ABPV and CBPV in Coimbra, and we had no CBPV in Romania. And Nosema apis in general was not detected at all, and Nosema cerani was detected in all countries, but we had big differences in number of infected colonies and the severity of the infection. And for example, the Nosema cerani was very low in Nottingham and in Coimbra. On dead colonies we had not much information at all, but we could see in this one case that we had in these two lost colonies, in one we had very high deformed wing virus B and Nosema cerani, and in the other very high deformed wing virus B and high varroa loads. Looking at pilot B study, in average, you can see that these four treatments look kind of similar. The C colonies were the controls, the P colonies were treated, they were fed with pesticides, with acetylmiprid in September. F colonies were pollen restricted from mid-July till end of October using pollen traps. And Q colonies, the queens were removed in July. But we see differences in this treatment. The V colonies, these were not treated against Varroa destructor in the winter 2019 and in summer 2020, while all the other colonies were treated with oxalic acid by trickling in winter and spraying in summer. So summing up the pilot B study in 2020, it seems too early to show differences between the treatment, but the colonies that were not treated against Varroa destructor showed very high Varroa numbers and higher viral loads for deformed ring virus B and acute B paralysis virus compared to all the other groups. The Nosema infections in all treatments were higher compared to the Wageningen mini-apiary, and in all the colonies no deformed ring virus A, no Nosema apis, and no foul brood was found. So this is. Thank you very much for your attention, and I'm happy to receive your questions now.